Hi, Sean. So I wrote up the solution to the problem based off the information that you gave, and thank you for that information because it's not always very easy to write math in one line notation. But we have this integral here, and the first thing that I do is I separated it into three terms. So I take the first term from the numerator and divide it by the denominator of x to give me this x squared over x. Then the second term in the numerator, which is 3x, that goes over x. And then the last term in the numerator, which is 1, also goes over x. Everything stays over x because x was the denominator of all of them. Then I do some simplifying here because x squared divided by x is just going to leave us with 1x. 3x divided by x, the x's will cancel and just leave us with 3, and there's nothing to simplify for the 1 over x. This next step here is optional, but I took the time to separate this into three separate integrals, one for each term, because I'm going to integrate each of these individually. Integrating the first one, we're integrating just x. We increase the exponent by 1 and divide by the new exponent. The old exponent was 1. We didn't see it there, but x with no exponent on it has an exponent of 1. So we increase the exponent up to 2 and divide by the new exponent of 2, which gives us x squared over 2. Then in the second term, we're integrating just 3. We do not see an x there, which means there is an x to the 0. So I increase the exponent up to 1 and divide by the new exponent of 1, which really is just 3x. We don't need to put those 1's in there. And then the last integral, the integral of 1 over x, is a special integration rule that gives us the natural log of the absolute value of x. So now that we have integrated, we are now going to apply the fundamental theorem of calculus because we need to deal with these limits here from 1 to 2. And so what we're going to do is we're first going to plug in our upper limit of 2 into all three of the terms that we got when we integrated. And that's how I get these first three terms here. I've replaced all of those x's with 2. And then we subtract because that's what the fundamental theorem of calculus tells us to do. And then I'm making sure to use parentheses when I go in and plug in my lower limit of 1 into all three of the terms here because we do want to make sure we're subtracting everything we get when we plug in 1. And then I just do some simplifying in here. 2 squared over 2 is 2. 3 times 2 is 6. Natural log of 2 is just natural log of 2. 1 squared over 2 is a half. 3 times 1 is 3, and the natural log of 1 is actually equal to 0, so I didn't even write that term. And then I just finished simplifying and combining my like terms to end up with the final answer of 9 over 2 plus the natural log of 2. Please let me know if you have any questions. I would be more than happy to help you.